Topic of presentation is requirement engineering for mobile banking application case study. And on the one hand, I represent National Aerospace University HAI. On the other hand, I represent Ukrainian outsourcing company Artkai, which is developer of software. And my presentation is about business analysis, since I'm working for Artkai company as a business analyst. So some idea about business analysis in accordance with business analysis body of knowledge, BABOK. This is practice of enabling change in an enterprise by defining needs and recommending solutions that deliver value to stakeholders. And business analyst is somebody who performs this task for changing implementation. And concept and framework of business analysis includes these 6 entities, what was mentioned on the previous slide. So we need changes in company, in organization, and these changes come through some solutions. It can be IT solutions or some offline solutions, and these solutions are highly dependent on the context, and these solutions need provide some value to stakeholders to cover stakeholders' needs. About requirements, business analysis considers 4 levels of requirements. Firstly, it's business requirements. After that, these business requirements are transformed into stakeholder requirements. After that, to solution or functional, non-functional requirements. And during transition from one company state to another, we can have as named transition requirements. Another important framework which covers some part of business analysis is requirement engineering. And there is International Requirement Engineering Board, IREP, which produces some useful documents in this area. So requirement engineering is the systematic and approach to the specification and management of requirements to cover goals of stakeholders' needs, and these requirements should also minimize the risk of delivery a system. And some quite obvious information, but about value of high quality requirements. When we design software and we inject occasionally some error in the software code, and we find these faults and fix it, and it costs 100 times less than the same error discovered during maintenance. So requirement engineering and business analysis, it's a really valuable activity during software development cycle. Another statistic is about root cause of industrial control system incidents. And here we see incidents because specification errors, 44%, also design and implementation, installation, commissioning, operation, maintenance, and modification. And in fact, modifications are also based on the specification. So the most part of problems during operation of industrial control system is because non-sufficient quality of requirements. It's about motivation. And this my presentation is mostly focused on the requirements architecture. And what is this? BABOK states requirement architecture as a scope of requirements, including relationships between them. So it's quite obvious, and maybe more detailed definition is about requirement architecture as design, structure, and behavior of the current and future states of structure in terms of components and interaction between these components. And analysis and synthesis of requirement architecture is challenged because it's not completely addressed in known research. And if we are speaking how to represent, how to implement requirement architecture, I propose very simple and useful model as feature tree. No, I will demonstrate it on the next slides. And this requirement architecture also introduce as named reduced requirements, reused requirements. And requirement architecture in these terms is conjunction of feature tree and reused requirements. And our case study is mobile banking application. And this table represents typical modules of banking application. It includes onboarding, home screen settings, also the most important features of banking application is operation with cards and accounts and different payment and transfers. Also, the user of banking application can apply for some bank products like deposits, credits, and also can generate reports about his accounts and cards. And about feature trees, yes. So we can consider this table as a sample of requirement architecture. So we have models and we have features, and it can be represented in a table view, and also it can be represented in a graph view. But I think here the table would be more sufficient than a graph. The next requirements usually are described in some view. Very common approach in software engineering is description requirements in Gherkin. What is requirement specification language, and it's simple. It includes very short set of operators. The main concept is use such trinity as given, when, then, and given is precondition, when is a trigger, and then is outcome after trigger. After that, we would like to research different type of requirement architecture in view of feature tree with reused requirement injection, and we would like to choose the most appropriate requirement architecture from the point of view of quality of requirement. And this is an example how can we represent requirement architecture. So this is basic feature, user login into the application, and for example, we have login with email and password. So on the login page, the user need to enter email as login, and the user need to enter password and press the login button. But also there are some validation rules. So when user during the user enter a mail, our front end need to validate this is a mail has the correct format. So a mail should include add, dot, and the sufficient format. But after the user presses the login button, we need to match email and password pair is already on the backend of the application, and this pair is validated against our database includes such records with email and password which was entered by the user. And if it was validated, then the user is logged into the application and drops on the home screen. So in fact, this scenario, these requirements includes functional requirements plus validation rules. And here, these validation rules are injected directly in the requirements. So we have functional requirement. Well, for example, the user is logged into the application and user drops into the home screen, but also we have a validation rule when email and password pair should be validated, and this is not centralized approach to describe requirement architecture. Also, could be another approach with centralization, and I propose to consider it on the next page. Here we have module level centralization, and here we have application level centralization. And it's quite convenient because if we have the same validation rules, for example, for different requirements or for different module, we can collect it in a general validation rules table, and requirements will include links to this table. But a difference is we can centralize this table on the level of module and on the level of application. So I take validation rule as example, but also it could be a different kind of reused requirements. For example, requirements to notifications, requirements to security, requirements for multi-factor authentication, requirements to authorizations of user for different roles, and so on. And for all this kind of reused requirements, we can use requirement architecture without centralization, with module level centralization, and with application level centralization. And now an idea is to select which kind of requirement architecture would be the best from the point of view of quality of requirements. And here we have some simple comparison. For example, if we are speaking about hierarchy compliance for centralization, yes, we have hierarchy in view of tree, but for module level and application level, if we are looking for this kind of requirements, it's not a tree form graph. We will have some cycle in this graph if we represent requirement architecture in a graph form, and so on. Centralization, injection level for reused requirements, and so on. To understand which architecture, which requirement architecture would be better, we implemented some case study. So this case study is from the real life. So my company and I'm personally is involved in development of some mobile banking application, and we need to implement different version of this application. No, in fact, it's not different version; it's different kind of application for three different countries. So we developed three different application for three different European countries with the same functionality. So the scope of requirements for these three versions was very similar, but for each of the version requirements architecture was written by different kind. So for the first application, it was without centralization. So all reused requirements were injected in the requirements and acceptance criteria text. For the second version, reused requirements were collected on the module level, and for the third version of application, it was application level of collection of reused requirements. And a question was how to measure quality of requirements. Well, there are different researches in this area, and there are different approach. But for context of our project, we selected such metric as number of requests from development team. It was tickets in Jira tools. So when developer had a question about some clarification in requirements or in acceptance criteria, this developer made a ticket in Jira, and it was a request. So we counted number of such requests for every of the module, and got total amount of requests for each kind of application. And after that, we calculate average number of requests. It's 135, and we calculated deviation from this average amount for numbers of requests. And you can see results. So the best was requirement architecture with module level centralization. After that, requirement architecture with application level of centralization, and without centralization was the most not understandable for developer. And this is the main result for this case study. So conclusion is the following. We discussed three different type of feature tree based requirement architecture with variation in reused requirement injection, and we performed a case study with the involvement of three independent developers team to select the best requirements architecture. And number of requests from development team we qualified as a metric to analyze quality of requirement. Our hypothesis was that decentralized requirement architecture and a completely centralized application level requirement architecture both represent some extreme points of view, and centralization module level requirement architecture is the mostly balanced approach. And our results confirmed this hypothesis, and we got more than 15% improvement for number of requests for this kind of requirement architecture. our result might support quality of requirements improvement for complex project, but of course it's only one case study, and we need more statistics to be completely sure in these results. And that's all. Thank you for your attention.
Thank you very much, Vladimir, for your report. Who has a question, please? Okay, I have one question. Vladimir, I sure you know the standards ISO IEEE life cycle process requirement engineering.
Mhm.
Will you implement rules from the standards to your approach?
Mhm. No, about these standards, of course, we are not following in details to this life cycle models, but of course, we have requirement stage, we have implementation stage, we have testing or quality assurance stage, and we have commissioning and maintenance and operation stage, but not in details. About this kind of standards, maybe the most usable for us is IEEE for requirement specification. So for some contracts, we have requirements from our customers to implement requirement specification in some strictly well-defined format, and in this kind we follow IEEE 729, I think.
Thank you very much for your answer. Who has additional question, please? Okay, no question. Thank you very much all.